All right, it's your Unit 5 Part 1 review video key. Let's get right to it. No time for small talk. First, we're doing cube root and simplifying this thing. So it's similar to when we do square roots and simplify, like 24. We break it into 4 times 6 because we know what the square root of 4 is, 2, and the 6 stays underneath the square root. So we chose a perfect square factor here. We need a perfect cube factor right here. Spoiler alert, it is 27 times 5. And we do that because we know what the cube root of 27 is. We know that it is 3. So you end up with 3 on the outside, cube root, and the 5 stays underneath because we didn't cube root it. Okay, I'm going to get rid of that because it doesn't actually have anything to do with that problem. Now when we include variables, so we do the 16 the same way, but 16 is a perfect square. And then with variables, we want square roots now because we're doing a square root, not a cube root. So we break everything else into squares. So x squared, y to the 4th is y squared, and z to the 10th is z squared 5 times, like so. And we want everything to be written as squares because we can square root squares. So now I just do the square root of this, square root of this, square root of this, and they all come outside of the radical and are multiplied together. So it's 4 from the 16, x from the x squared, a y from the y squared, another y from the other y squared, and then we have 5z squared, so we end up with 5 z's out here. This is not work that you need to show me. If you can do this in your head, I think that's fine. But then all these things are multiplied together, so instead of y times y, I'm going to write it as y squared, and instead of z times z times z times z times z times z, I think I said enough z's, I'm going to write it as z to the 5th. So that's how you do that one. Box in that answer. I'm going to change the color of these problems as we go. Why not? All right. And then over here, now we have a 4th root, so we want everything to be a perfect 4th power. 81 times 2 is 162, and x to the 8th, we're going to make x to the 4th, x to the 4th. The 4th root of 81 is 3, so you get 3. We can bring out an x from here and an x from here, giving us x squared on the outside, and that 2 stayed underneath because I did not 4th root it. And so that's how you simplify problems of that type. Okay. Rewrite the following in exponential form. So with using exponents only, we should know that a square root means a 1/2 power. So what we have so far is this. This is one way to think about it, at least. And then we kind of say how we distribute the power to each of the things in here. It's not really distributive property, but it is kind of what happens. So you end up with 97 to the 1/2. And then this is power to a power, which is when you multiply the powers. So 3 times 1/2 is 3/2. Or you can know that there's actually a 2 right here that we wouldn't normally write. And then using this idea, like the nth root of x to the m is the same as x to the m over n power. Remember, whatever your denominator is the root you're taking, and whatever your numerator is the power right here. So this is our numerator, this is our denominator for our k, which is 3/2. So that's another way to think about it. So it's kind of up to you how you want to think about it, of course, but there's 2 different ways you can kind of look at it. Okay. So we can do the same thing here. Now I'm going to do it the more of the shortcut way. I know it's 1/3 power. It's not really a shortcut, I guess, but so it's going to be 17 to the 1/3, and then this is my denominator, this is my numerator. So x to the 2/3, y to the 5/3. That's all you got to do. So I think it's a little faster if you think about it like that, but if you prefer to do it, this way, that's fine too. It just takes a little bit longer, but you should not be crunched for time, I don't think. Rewrite the following in radical form. Notice the difference between these 2 problems. These are both in the parentheses, so they both have a power of 4/5. Only the a over here has a power of 2/3. The 10 just has a power of 1 right there that we don't normally write. So this is not going to go into a root at all, but we'll get back to that one. So on number 6, we have, again, this is our root, so it's going to be a 5th root of xy to that power, so to the fourth, which can also be written as the fifth root of x to the fourth, y to the fourth, like that. I think I would accept either answer, so that's fine. All right, so on this one, like I said, only the a has a power of 2/3. So that, again, this is the root. So it's a cube root of a squared, and the 10 is just hanging out on the outside because it just has a power of 1. So it does not go under a radical at all. All right, simplify the following, leave answers in exponential form. So this, what we're going to do here is similar to like when you do x squared times x cubed. You should know, hopefully, that that means you add the exponents, you get x to the fifth. Because this means 2x's multiplied together, 3x's multiplied together, so total we're multiplying 5x's together. So that's how we're going to deal with the y's right here. The numbers themselves, we're just going to multiply those numbers together because they don't have different powers other than 1. So that's just normal multiplication, like 2 times 4. If it was like 2 squared times 2 cubed, that would be 2 to the fifth. You would not make it that of 4 because we don't multiply these. This number tells us how many times to multiply this number by itself. So you would not multiply the bases in that case. We're only doing it here because they don't have exponents other than 1. So 2 times 4 gives me 8, and then it's y to the, I'm going to show it here, 1/3 plus 1/6 power, which you can just do on your calculator, but you do get 8y to the 1/2. And notice how only the y is to the 1/2 power. I did not put the 8 in parentheses. All right, I use that. Okay, on this one, this is like doing x to the fifth over x squared, which if you remember when we learned this a long time ago, this is 5x's on top, 2x's on the bottom. So you're multiplying by x 5 times, but then dividing by it twice. So 2 of those cancel, leaving you with just 3x's, which is x cubed. So the shortcut being you subtract the exponents in this situation. So the 5 is just a 5. It just hangs out there. There's not even another number in the problem. And then these two things is what we deal with. So remember, this is actually p to the first right here. Or sorry, whoops, this is p to the first right there. The 5 stays 5, so this becomes 5. P to the, this is where you subtract the exponents, 3/4 minus 1, which is 5p to the negative 1/4. So I'm doing the top exponent minus the bottom exponent, and then the answer goes on top. But no negative exponents in here. The directions should probably say that. So this equals 5 over p to the 1/4. Remember, a negative exponent just means this thing goes to the bottom. So that's how you do that. Now, in this problem, we kind of say, even though it's not really what we do, we kind of distribute this. It's not really what distributive property is, but this power of 2 does go to both things. Now, this is power to a power rule, like x squared cubed, and that means x squared times x squared times x squared, which is x to the 6th. So this is where you multiply your exponents. So here, this is going to be 2 squared, because there's really an exponent of 1 there, so 1 times 2. And then we're going to do a to the 1/3 times 2 power, which is a to the 2/3. And you could, instead of 2 squared, you could write it as 2 to the 4th. Or, I mean, as 4. If you wanted to, that would be fine. And then that leaves us with solving equations. When we solve equations, the first thing you want to do is isolate the radical. So whatever's underneath, doesn't matter. Get that whole thing by itself, so we got to get rid of this 10. So first we're going to add 10 to both sides. I'll show all the steps. So you get square root of 2x minus 3 equals 5. Now to get rid of a square root, to get rid of that square root, we got to square both sides. So we square, the square root goes away. 5 squared is 25. Now you have a very basic Algebra 1 equation that you should be familiar with. Add 3, 2x equals 28. Divide by 2 with this color, and you get x equals 14. Okay, you got to check it. So to check it, plug in 14, and you get 2 times 14 minus 3 under the square root. Then the minus 10 is afterwards, and we got to see what that equals. Does it equal -5? That's what we're trying to figure out. So first do 2 times 14, and you get 28. And then 28 minus 3 is 25, so you get the square root of 25 minus 10, which is 5 minus 10, which does in fact equal -5, which was the original thing, so everything checks out. Yay, it works. All right, number 9. Oh, sorry, let's go over to number 8. I guess we'll go numerical order here. So now when you have a power, you still want to get this thing by itself. That whole parenthesized thing. So we got to get rid of this -2. I saw a lot of mistakes when people were working on this in class. You have to divide by this number on both sides. So that leaves us with x plus 7 to the 1/3 equals -3. To get rid of a 1/3 power, you raise both sides to the third power. So we're going to cube both sides. Like that. That cancels these out because you multiply the exponents in this situation. 1/3 times 3 is 1. So you end up with a power of 1, which is what we want. So you get x plus 7 to the first, which we don't need to write. You know, it's technically like this, but to the first power doesn't do anything. And that equals -27. Subtract 7, and you get x equals -34. Okay, and then I'm going to box that in even before I check it, but we should check it first and make sure it works. Please make a rectangle. Thank you. All right, so now we're going to check it. And we get -2, so I'm plugging in -34 for x. And we want to make sure that does, in fact, equal 6. So we do the parentheses first, -27 to the 1/3. Now we got to do the 1/3 power, do the exponent, and for order of operations. So -27 to the 1/3 means cube root, so that's -3. And -2 times -3 does, in fact, equal 6. Which is what the original thing was set equal to. So that one works. Number 9, we have a 4th root. The 4th root thing is already by itself. There's no numbers on the outside. So we're good there. We can just start doing the problem. So raise both sides to the 4th power to get rid of the 4th root. And that leaves us with 5x minus 4 equals 16. Add 4 to both sides. And you get 5x equals 20. Divide both sides by 5, and you get x equals 4. Okay, so now we got to check this down here. And so you get the 4th root of 5 times 4 minus 4. And that's the 4th root of 20 minus 4, which equals the 4th root of 16. And the 4th root of 16 is 2. So that does not work because it was supposed to equal -2. You got to go back to the original equation. Notice how all I'm doing is plugging my x into the original thing. I'm not manipulating the original thing at all. Okay, this one we have a square root equals a square root. So you can either square both sides because they're both by themselves. There's no extra numbers. Or use logic and say, okay, if square roots of two numbers are equal, then the numbers underneath themselves must be equal. So you can kind of just drop the square root altogether and get 6x plus 12 equals 23 minus 5x. Now there's different steps you can do next here. I'm going to add 5x to both sides, add 5x, leaving me with 11x plus 12 equals 23. Subtract 12, 11x equals 11. And finally divide by 11, leaving us with x equals 1. Plug that in to the original equation, and you get 6 times 1 plus 12, that's under a square root, equals square root of 23 minus 5 times 1. And that gets you 18, square root of 18 equals square root of 18, which is true, so it works, not an extraneous solution. So that works there. This one works here. So those are, oh, sorry, no, that one doesn't work. So this one was extraneous. And there you have it.